My name is Jorge Morlet. I'm the Field Sales Director for CloudFrame. Before I start, I'd like to talk a little bit about me and my experience because I think that'll help you understand why I'm driving this session this way, because I'm a technical person. Well, first of all, I'm not the guy in the picture. I'm not that handsome, but I have a little bit over 30 years experience working in different in IT, of course, but different fields of IT. Started as a developer. I did Adabas, Natural. I did some COBOL and Fortran, and maybe by early 2000s, I was able to, for the first time, turn off a mainframe. That was a very strong experience. It was very challenging, and I just keep coming back to the mainframes. And the past maybe 10 years, I've been working on integration projects and migration and modernization projects. And for the last year, I've been with CloudFrame. Very exciting journey that we've been following here, because we have very innovative products. I'll talk a little bit about the products, but that's not the intent of the webinar. My intention here is to try to help you a little bit on making the decisions on how to get a successful project while you're doing some shifting or trying to modernize your technology. Okay, so let me start by talking a little bit on what is shifting COBOL Compute, or what is that we see as shifting COBOL Compute. Basically, it's moving the compute or the execution of your COBOL program into any other platform. Could be any other environment that you already have, or an environment that you will have to set up to make this shifting. Okay, the big difference that we are showing here is that we're shifting the COBOL compute. And so this is not exactly a lift and shift project. On lift and shift projects, what you're after is basically to get rid of your technology. We are not at this point, or with this vision of these projects, asking the customers to really deprecate their mainframes. What we're offering the customers is a way to reduce the costs, a way to be providing your own company with internal solutions to basically reduce the utilization of resources within your organization. And so the GPPs, we know that they are very expensive resources. That's the CPUs in which the COS actually executes within the mainframe. And we know that they're expensive resources, and that's why we're talking right now about how you can shift that COBOL compute to other platforms. Okay, what are the reasons? Well, I already mentioned the costs. Okay, so not only reducing the present costs, but also avoiding future costs. Okay, typically organizations that they run over mainframes, they have yearly increasing of 20% or maybe more in their invoicing. They are charged by MSUs and MLCs, which is the licenses as well. So not only the direct consumption of the hardware, but also the utilization of the software gets affected, and the invoicing increases year after year. And we're also allowing, by shifting the COBOL compute, we're also allowing to optimize the use of resources, and not only the GPPs, but also other resources that they get affected by getting your mainframe to the limit. If you overnight, you may have 8-10 hours on your batch window that you have the computer completely hijacked for by your productive processes, then you don't have room to do some tests overnights or things like that, because you're taking from the developer some resources that they may need to produce. So even your new solutions, your new developments, they may be also impacted for having your resources to the limit. So this will also allow you to ensure that achieving your SLAs by relieving, all batch production pressure. This is very important, and it is also very important that you can eventually, in the batch chain, think finally, or for the first time, to being able to decouple some of the non-so critical parts of the operation, like, just to mention something, some reporting or some specific end of day or end of month processes that you can eventually decouple and execute outside of the mainframe, get the information or the results back, and you relieve your batch production very, very importantly. So, and probably one of the most important things is reduce risks. You know, people and companies and organizations that they work in mainframes, they know that perhaps the most important characteristic of this technology is reliability. So if you're working in a reliable environment, what you want and what you're after is reducing risks. Okay, so we're providing and allowing you to have a project that will reduce the risk to the minimum possible while you retain the business logic and the processes as they are. Okay, what risks you can find here could be maybe obsolescence in your processes, maybe part of your code or part of your applications that you're running all over, they may be not supported in the near future because it is very expensive to keep paying for those, and you know, or probably just going over the peaks and the capacity that you have contracted under contract. Okay, so those are some of the reasons that we foresee as triggerers for going after a shift compute project. Okay, now how is that you can, you know, take some COBOL and make it run in another platform? Well, it is done by cross-compiling. Okay, cross-compiling is the capacity that you have to take some code, cross-compile, and then execute that code in another platform. Okay, concept is very simple. It is not simple to do that, but if you have the proper solutions and the proper help, you will be able to do that very simply. It is very important to mention that particularly COBOL, it behaves differently when it is just the source code versus a compiled code. The COBOL compilation has some compiler options that can affect the behavior of the code, how variables behave during the process, and even if depending on these variables, you can enter or not into some cycles of the process as well. So this is very important to mention. Work with compiled code is differently than working with the source code, and CloudFrame has taken care of that already. Okay. But it's an important consideration for the cross-compile process. Now, once you cross-compile your COBOL, you should be able to run in another environment, right? What are those environments? Well, basically, there's many target languages, but the most frequent that it is in the market right now, it's Java or probably C++. And in Java, the good thing about Java is that the execution of a Java compute, it's very simple. The only thing you need is to have a JVM running anywhere. And that anywhere could be within the mainframe in a USS or IFL, could be another bare metal. Potentially, you know, you're deprecating some old technologies, old servers that they may still have the capacity, and you can reuse those. Or you are already working with some virtual machine technology, either on a cloud or on-prem, you can use that. Or if you know that this is a compute that you can eventually separate into pieces and do something like a parallelize or things like that, you can maybe even move to a smaller compute intended type of like containers or serverless. Okay. What are the criteria that you should use to define where to run your compute? Well, obviously costs, the easiness of provisioning, the persistency of that environment, depending on what it is that you want to do, the capacity based on what type of application you are shifting. You need to make sure that this is going to have the capacity. Also, data affinity, which is where is your data? Do you want to keep your files running still within the mainframe? If yes, you probably want to use the USS because the data is going to be within the same environment. If not necessarily, you may want to use something that is outside of the mainframe. But the most important thing is that you should be able to make your decision. based on the capacity of shifting your compute, with no tights. And this is the case of shifting your compute, your COBOL compute, into a Java. And if you do that, you have a lot of options. Okay. Now, automation is also very important. It is a thing that will help you, particularly with consistency. And I'm highlighting the word consistency among all of these because I think it's very important that when you have consistency, you can speed up the process. You are reducing the risks. You are basically have the capacity to improve over time, because that consistency will give you a starting point that you will not fail. So improve over time and gain efficiency. It's something that you can focus on when you have a consistent transformation. It is very important that when you're doing your cross compilation, you find clear ways to make this repeatable. And what we do is we find patterns, and we recognize those patterns, and then we consistently transform those patterns the same way every time. So this is going to avoid you or stop you from having risks. Okay. Of course, automation will shorten your project and reduce the risks and costs, but most importantly, is going to minimize the organizational impact. If you're automating, you need to take less people from the everyday operations, their everyday activities, and they can keep doing what they do, which is improving the applications. Okay, this will also allow you to do the processing or the project in-house, very important, and to keep control to yourselves. Okay, so as an organization, it's very important to keep the code inside, very important to keep all the operations within your premises. Automation is a way to do that as well. Okay. When time, 15 minutes. Okay, from here, I'm going to jump into how to make your project successful. It is very important to take in consideration several aspects of the process. And if you really want to give something to your decision makers that will not fail, and you did not spend a lot of time doing a project that is not going to succeed, make sure that you cover at least these points that I'm going to mention in the next few slides, and we can discuss, and I'll be more than glad to receive any other ideas if you think that I may be missing something. This is based on experience in previous organizations, experience on this organization. The assessment and project management, it is very important to succeed. If you try to go big, you will fail big. Okay, so first of all, try to work on realistic timelines. Okay, the process of a project management is based on these simple 4 steps: initiation, planning, execution, and closure. Okay, if during the initiation you try to go very ambitious, or you don't know at all what is that you're going to do, you already are in trouble. Okay, so make sure that during the initiation you know where to start. Okay, and probably this is the question that I receive the most when I'm talking to customers about modernization projects, digital transformation, systems integrations. Where do I start? And we've helped some customers to really get to the right starting point, and also have a lot of information to back up that decision. Okay. One of the things that we know is that customers can obtain the major CPU consumers applications for a day or a period of time. Okay, so what we typically advise the customers is, let's go find those guys. Those are the typical candidates that we want to migrate into a Shift COBOL project. Okay, so we can help them, or their services provider can help them to gather a list of the top 20, top 30 major CPU consumers. Okay, from there, it is also you have the capacity to find which of these processes, major consumers, they will be easy to decouple. Okay, and easy to decouple means that you can just consume a few files, then process everything, and then get the output. Or you're going to have accesses during the process to some data, but it's going to be minimal. Or you can basically reproduce and take this part of the operation to a separate compute without affecting any other parts of the process. Typically, customers, they find like at least a third of this first list is easy to decouple. So we may be talking about 5 to 10 applications by then. Then, and I'll talk in deeper about this later, select the good candidates. The good candidate application, it's basically what are the ones that are going to behave the best in the target architecture. Not every architecture it's intended to work or to run everything. And so it is very important to select your good candidates. When you have your good candidates, we advise the customer, let's take 2 or 3 of those good candidates and let's make a business case. Okay, let's project what are the savings that you're going to have on this. And we, as in CloudFrame, we provide for both of our products what we call the calculator. It's a very simplistic model that will save you a lot of time and a lot of money on resources to doing some sort of consultancy services to get to a number. And that initial number, we are really doing very good and accurate estimations. Okay, so you can tell if I can shift these COBOL computes, these applications to these new other platforms, I'm going to be saving this amount of money. And for me to be able to run a test about this, I need X amount of money. I need this budget. So you can go to your decision makers and tell them, I've already done this selection, and I know that if I take these 2 or 3 candidates and I made a shifting process on this, I will save us this amount of money. I need this budget to run a proof of concept. Okay, and then you have a small blast radius. You know what is going to be affected. And it is important for that to happen not only on the selection of your candidate, but also during the execution. And it is very important to mention, there's customers that they've tried these kind of projects, they always face some issues on the blast radius. They realize that as they are converting one program, that program is calling another one, and the second one is calling a third one, and this routine is actually accessing a table in a database that is not migrated, and then you need to bring that information to the new environment, and then the blast radius actually starts to getting bigger and bigger and bigger. Make sure that you work with technologies that will allow you to control very harshly that blast radius. If you don't do that, better don't start, because your planning is not going to go well, okay? And your execution is going to go even worse, okay? So this way you will get a real and a moderate budget to execute just your POC, because you know what's the target, because you know what are those 2 or 3 applications that you're going to migrate, okay? During the execution, make sure that you execute impeccably. Make sure that you know what is it you're going to do, how is it you're going to do it, who's responsible of what. Make it also automated. If you do automation, you know that you will have reliability. Okay, and then for the closure, if you did the first 3 steps properly, then the closure should be just gather results, let's put this together in a report, and let's take this to the high level management to make a decision on and start doing shift compute projects. Okay. Now, how to build a solid business case? There's a lot of elements that you need to take in consideration. We have thought about these 6 at least, could be others, and I'm opening the door to see if anybody wants to suggest any other. I'm going to describe how we see each one of them and how you can eventually take control of them. So the first is the strategic context. From the business standpoint and from the technology standpoint, both, where am I and where do I want to be? Where do I want to go? what is my major challenge, my biggest challenge that I have on my operations, on my revenue? Do I want to increase revenue? How do I do that? Do I need to generate new operations, new functionality? How do I do that? I mean, I need more compute. I need the capacity to have, better response times. These kind of questions that will guide you to comply with the strategic goals of the organization. You need to analyze to decide where do you want to be and how you can get there. Most of the times, the answer is going to be you're going to have to do some digital transformation, some migration projects, and get some agility on that process and shift your compute. It's also going to be the response in some of the times, if not most of the times. Then make an economic analysis. Like, what is going to happen if I do nothing? What is it going to happen if I do a manual migration? Or what is it going to happen if I do an automated migration? Once you have that, the response is going to be very simple, okay? What obstacles do I have? Maybe lack of resources. This is very typical. My people, they're already busy. I don't have time, or or maybe some people, they don't have interest on this because they're not aligned with the strategic context. So make sure that people are aligned with the strategic vision and these goals are spread all over the organization. So when you come to people asking for time, they'll show the correct interest. Okay. Now, some of these, or most of the organizations, they have a strategic goal because they have a compelling event. They have a trigger, like losing market share, or not getting the profitability they want, or any of these reasons. There's got to be a strategic goal. Use it. Use that to sell your project internally. Okay. And finally, well, make a deep analysis on the risks. Okay. What if this doesn't happen? What if make an analysis on the operational impact, make an analysis on the business impact. Okay. And like I said at the beginning, not only make an analysis on the risk of doing the change, also make an analysis on doing nothing, because sometimes could be more impactful. Now, for the execution, I've divided the execution in these steps, which is also planning, which is planning the installation. Make sure that you have very clear all the prerequisites. You don't want any surprises, okay? If you happen to have to probably set up a very expensive environment and you ask for an incorrect budget, you could get into huge trouble. So, and I like this saying, $1 million size budgets is putting at risk $1 million size failures. So make sure that when you're planning, you know all the prerequisites and resources that you're going to need, the people, the time, the process, and the installation requirements. Everything is ready before you do anything, okay? The installation process, if you plan properly, should be smooth, should be not taking more than a week, and you should have everything ready in your environment to start doing the testing, okay? For the testing, very important, make sure that you have a stable baseline, okay? Make sure that it is a repeatable process that is not going to be very complex to basically rerun. Make it so when you run your baseline, you do it once, then the next time you rerun it and you see that you have consistent results on the baseline, then you're ready to compare against the new environment, right? So it may sound silly, but I've seen customers that they cannot reproduce the baseline. And so make sure that you have that under control. Okay. And then again, gather the results. Don't try to go very big and deep into the bushes. Just be clear. What is the time and resources that I consumed before and after? And that's going to give you 4 or 5 indicators, 6 indicators at the most, of the status before, the status after, and if you got the functional equivalency, yes or no. And with that, you should have enough information to provide. Go back to your calculator and make sure that you have really accurate numbers, okay? and the business case, it's going to be fairly well supported at this point. Going a little bit deeper into the execution process, make sure that you know who's doing what. Okay, I already mentioned about the technical resources, the hardware and software, but also people. Nothing's going to happen if you don't have the people, right? So make sure that they all know what they're going to do. Have a project manager. I'm putting this as optional, but I strongly recommend that you have a project manager during the entire process. And I'll explain that later in some things that are key for the project manager to do as well. But the application SME should know how the application works. When you're installing in the mainframe, you need a system programmer. Make sure that you have them available. As you're going to shift your computing to another environment, you need an architect on that environment. And of course, some people with experience on that new code that you're generating. So plan those roles, make sure that everybody is there, make sure that you are not going to miss or make a mistake there on the resources, okay? And I was also talking about, the project management. So skill communication is obviously key. But a project manager should be taking care of the full organization of the team, the conflict management, decision making, but most important is the time management. So if you have the right project manager, you will avoid surprises. And I know most of you have done this type of projects, and you should know, but project manager is also key. And if you have a good one, you will immediately identify risks and potential problems before they happen. Now, the core of this presentation to me, and the most important section, is to talk about the success factors while you're shifting your projects, okay? How do you ensure that this is gonna be the win that you are after? And I already mentioned, and I promised I was gonna go deeper about selecting the right application, okay? Because your source environment it's been behaving the same way, executing the same process for years. You already tuned that for years. You already know that this is efficient. You know how much time it takes, depending on the whatever situations you have. You know everything, but you don't know much about the target environment. So the first thing you need to make sure is that this target environment is going to be working smoothly, and it's going to be prepared to receive what you're taking. So we have this advice on the good candidate applications to tell what is the best way in which Java will run a COBOL Compute, okay? And when it's about the access to sequential files, make sure that you are reading those files in a sequential mode, okay? And so the heavy computation part of the process that is being done by COBOL is going to be done also by Java, but Java will have and will apply new techniques to make that sequential file reading optimized. And this optimization is something that has to be also automated to the best possible level. So when it's about accessing files, make sure that you have sequential access. When it's about accessing tables in a database, make sure that you are also doing reading through cursors. Cursor reading will allow Java to make some fetching, okay? And the prefetch is going to give a lot of power to do the shifting and computing even faster. And I've seen out of the box customers that if they use this type of applications, they're getting better performance on Java. And I know this is a myth, and I've seen customers telling this is never going to happen. Well, I've seen it happening up to 35% in a big volume computational process in which Java was doing some prefetch for sequential files and cursors readings, and it was getting better performance. So it is feasible. Just make sure that you're using the right applications. And we at CloudFrame, we can help you ensure how to do that. Okay. So better, we are taking in consideration during our migration processes that we're going to a new platform, and customers sometimes they're not only working with new technology which is now object oriented. Sometimes they want to go far, and beyond. They want to, convert this into microservices. They want to convert this into real event-driven applications. So if you really want to do that, is it possible? Yes, it is possible, but it's a work that needs to be done based on a by case scenario. So if you already selected these applications and they're working and performing correctly, you still can do more? Yes. Okay. I already mentioned these type of applications, they will be very easy to decouple because you read, you process, you write. And the more you read, the more you process, the more you write, your compute is going to be more efficiently utilized. And then you're saving more money. Okay. Sounds simple, but it is just like that. And very important, if you're doing it this way, you're also reducing the problem of the data gravity. If your data is not, local, and you have to read and write every time just one single record, you're getting your compute compromised. You're not getting the best out of that compute. And so I think it is very important to work also on the optimization of the access to whatever data you're processing. So batch processing is basically meant to do that, heavy computational processes. Let's take advantage of that. Let's make sure that the Java is optimized, and let's put your new, less expensive platform to do that shifting. Okay, so one thing that you should be getting out of this selection of the good candidate application is confidence, because you will have undeniable evidence that you have better performance. And that 35% that I'm telling you, it's hard numbers that we got from a customer, and this is real. So the customer does have the confidence right now that he can roll out this and save a lot of money. Now, success factor number 2, it's get the right outcome. Okay, and to get the right outcome, you have to make sure that you're doing proper testing. I think we already mentioned volume testing. Yes, it is valid at this point. We're not saying no. It is important because you're going to project savings, right? But make sure that you have clear goals. Make sure that you have clear success criteria. I already mentioned, make sure that you have a clear baseline and that is repeatable and that you can go back as many times as you need to that baseline. Okay. If you have edge cases, also define those edge cases and make sure that they're covered. And I think I already mentioned about the volume. Yes, the automated solution should support volume, because otherwise you're not going to be able to project your savings, right? So that's what I see on a proper testing process as, the success criteria, probably the most important thing on defining your testing. Okay. Make a precise validation. And this is in the bottom already. Compare apples to apples. Make sure that the inputs are the same, the outputs are the same. All the potential tables and rows that you change during the process, they are completely identical. And you can automate the validation process as well. You can do it manually, wherever you prefer. The only differences that you should have could be the timestamps of the execution in itself. Okay, but other than that, you should get complete functional equivalency. There are some comparison tools within the mainframe, the IBM supercompare, others outside of the mainframe as well. One thing that is important is this is potentially different platform, or well, not potentially, it's a real different platform. So you, in the mainframe, you work and process everything as ABCDIC. Outside of the mainframe, pretty much all the technologies, they use ASCII. So make sure that the technology that you're using is taking care of that. Okay, so you don't put at risk that when you're running the compute, something is not properly translated, and then the information that you get back into the mainframe is not equal. So your process should take care of that as well. Okay. Data equivalency and precision, numeric precision is also a thing, and I already mentioned the importance of using compiler listings, because that is one of the things that also got affected based on the compiler options, and is the precision. The numeric precision and computes, it could vary a lot if you don't have the correct control over there. Okay, so that's why we work with compiler listings. And of course, continue to tune. Okay, you have cross-compile, you are running in a new environment, you work with the data affinity, you have it close, everything looks to be fine, despite there's going to be some work that you can do. You can still keep fine-tuning, working the affinity of the data, maybe even data replication, optimize the way you provision and deprecate the resources to make the execution. If these are dynamic resources where you're running the new compute, make sure that you provision and deprecate properly so you don't consume extra. That's an example for clouds. Just to mention, an example, in a cloud you can automatically deploy either VM or serverless or a container, then make sure that you're just using them during the process and then deprecate them. You can also optimize the COBOL itself, because that COBOL was meant to work with whatever type of accesses you had to those files. You can do some changes on the COBOL that are going to impact your cross-compiled code, and it's going to give you the best out of that new code. Okay, you can keep doing upgrades into your COBOL, take it to the latest versions and do things like that. So that's also very important for you to keep doing. And basically, there's the daunting thing that you're using all techniques in a new platform. So you have to work on all those techniques and make sure that you're getting the best out of things like caching mechanisms or data serialization or things like that you can get in Java, which you eventually do not get in other platforms. So I have 5 more minutes. Let me jump a little bit to explain, because I know that at this point many people should be saying, oh, how is this even possible? Is there a solution that can help me control that blast radius? Is there a solution that really can automate everything? Is it a solution that allows me to keep developing in COBOL and then maintaining or executing as Java? Yes, that solution is Relocate. We have customers in production running this, and we call this Relocate. Relocate is meant to do this process incrementally, move your workloads into zIIP or using USS or any other cloud platform, any JVM environment. It is very fast to implement. You're basically shifting your compute only. There's a very low risk because you have a very easy rollout process, and it has backward compatibility, which means you develop backward compatibility at 2 levels. One is the code, the other one is the data. The code level, you just you keep actually both modules. You keep your compiler COBOL module, and you can also have your migrated Java, and you decide which one you want to execute. When you execute the Java, of course, you're gonna take the compute to the new platform, okay? And then the data, you keep the data in the same repository where it is. Optionally, you can move it to the new platform if you want to work on that data affinity. Okay, so that's Relocate, and that's how we solve, and that's how we basically been taking customers into production with real results. Okay, this is a customer success case. An oil and gas producer, they took their energy futures trading application and they optimized using this methodology that we just described. They selected the good candidate applications, they passed this through the entire process, and they saved and reduced the MIPS consumption by 47%. So this is a reality. This is something that can happen, and most important thing is they really did rigorous testing and on performance and on functional equivalency and everything, and they got to take this into production. Okay, so I have 2 more minutes. Just let me jump very quickly into some frequent questions that I receive. And this is, do JCLs and procs need to be transformed? Not really. The only thing that you need to do is to change the line of the load library that you're going to be consuming in the step in which you are running the COBOL program. Instead of running as COBOL, you're going to run in the new environment using the correct load library, and that's it. If you want to roll back, You just take that line back and you keep running everything as COBOL. Okay. I think I already mentioned where can the Java bytecode be deployed? Any Java virtual machine version 1.8 and up. So this gives you the capacity to go to USS, IFL, any technology that you want to use. Can we maintain the Java source? Yes, well, you can, but we strongly recommend you not to do it. Because first, this is not beautified code. And secondly, it is also important that you keep control of all your changes and improvements into your code in just one single platform. And we recommend you to keep doing this in COBOL. Okay. And finally, and I think I've addressed a couple of times, what about the data? Well, it is important for you to optimize the location where you're going to keep your data and use, modern techniques like prefetch. Avoid replications or multiprocessing of data to, not to have problems with those operations, and do not change the format. I already mentioned. If you're processing everything as ABCD, keep it like that.
Thank you very much, George, for taking us through this. Thank you for everyone that attended today. Have a great rest of your day.